This video introduces the concepts behind 3D meshes or 3D models. And the things covered here are going to be applicable for working with models from script in Unity, but they're going to be basically the same wherever you go. So in other 3D gaming engines, in 3D modeling software, Maya, 3ds Max, meshes are always going to be built the same way. And to start out, we have to define points, a series of points that define our mesh. And really, at a minimum, we have to have 3 points, because 3 points gives us area. If we just had 2 points, we have no area, we have nothing to render. So our basic shape is going to be a triangle. And we can then go through and define multiple points. And once we have all of our points, and these are also known as vertices, so an individual one is a vertex, once we have these defined, then we need to group them up into triangles. And some modeling software and different things will use different shapes. They might use, say, a quad or some other type of polygon, but really, in the end, it all comes down to triangles. So we group our vertices into triangles like so. And once we have them all defined within triangles, we now actually have a surface. So we now have something that can be rendered. From there, we can go on and we can define normals. And so if I take one of these triangles and I just kind of flip it on its side, normals are going to be a vector that points out of the triangle. And normals are going to be defined on a per vertex or a per point basis. And from there, we can also define a tangent. And a tangent is going to be 90 degrees offset from the normal. So they're going to be orthogonal to each other. And then just from some simple math, I actually have a full 3D coordinate system for each point defined. So once I have my x and my y, it's relatively easy to just compute a z that points out of that xy plane. So I have a full coordinate system defined. Next up, I can define the UV mapping. And UV mapping basically tells us if I have a texture and I'm going to be wrapping it over this 3D object, how am I going to do so? So again, this is on a per vertex basis. And if I have some texture that I've defined, so in this case, I don't know, I have a tree, maybe with a little sun in the background, and I want to wrap this over my 3D object, then the UV mapping just tells us in the coordinate space of the image, so if the bottom left is 0, 0, and the top right is 1, 1, then where is each vertex? So in this case, my points might be there, there, and there. And this doesn't have to match this shape in 3D space. So I could actually say I could flip points around. So maybe the bottom left point is here, the bottom right point is over here, and the top point is down over here. So it's completely arbitrary. And so on a per vertex basis, we define a coordinate in this space, and this is called UV space. And really that's just so that you don't get confused with XYZ, which is how we use to define the actual vertex point in real space. So once we have the UV mapping, we can define another item on a per vertex basis, and that's a vertex color. And in this case, this bottom left one might be blue. Over here we might have green, and next up we might have red. And so this is then another piece of information that we can pass to the shader that's actually going to be doing the rendering on this 3D object. So it won't necessarily be visible right away unless you have a shader that understands it and knows how to use it. Just another piece of information that you can pass. So next up, we have mesh bounds. And bounds is simply a bounding box around the entire mesh that defines where the mesh actually exists in 3D space. So it encapsulates all of the vertices of the mesh. And this can be used then by, for instance, a camera that's going to be rendering a scene to determine whether or not an object is visible, whether any of its vertices can be seen by the camera, and therefore whether it should be rendered or whether it should be culled. From there, we have bone weights, and these are defined on a per vertex basis. And bone weights are going to be used with bones, and they're going to be used with skinned meshes. So when we have a bone defined for a mesh, then we simply define the weight that it has on each individual vertex, or in other words, the amount of effect that that bone has from 0 to 1 on each vertex. And then finally, we can define submeshes. And submeshes are a way to split out one individual mesh into a couple of meshes, so one 3D object into a couple of different individual meshes. And the reason we'd have to do that is that we can only apply one material to one mesh. So if I had a 3D object where I needed to use multiple different materials, say in one part of the mesh I wanted some shiny specular, and in another part I wanted some completely different effect, then I would define a submesh with part of the triangles, part of the vertices, and then a different submesh with other ones, and apply different materials to each. So now we've gone through and defined all of the basic parameters that we have for working with 3D meshes. And most of them are going to be defined on a per vertex basis. So for each vertex, we're going to have a point in 3D space, and that's just going to be an x, y, z value that tells us where this vertex is. We're going to have a normal, potentially, along with a tangent. We could have some UV mapping. We can define a vertex color. We can define a bone weight. And then outside of our vertex definition, we have a triangle definition. And since a vertex could theoretically be used in more than one triangle, then rather than defining a triangle for a vertex that would limit us to only one triangle per vertex, we have a separate triangle array. And that triangle array then contains triplets. So it will contain, say, vertex 1, vertex 2, and vertex 3 for that triangle. So we're going to have a list of triplets of vertexes that define our triangle. And so in this case, triangle 1 would be this vertex, and this vertex. Triangle 2 would be this vertex, and this vertex. And triangle 3 would be this one, and this one. And then finally, we have the bounds. And bounds are defined for the mesh as a whole. So a couple more notes before we wrap up this section. Just explaining a couple of these pieces in more detail, what they actually mean. So at a minimum, to define a 3D mesh, we need vertices and triangles. And when we have that, we actually have a surface that can be rendered. Now, with triangles, triangles actually have a winding order, it's called. They have an order that's important. And the reason for this is that most rendering is going to be done on a side basis. So for a triangle, we're going to have a front side and a back side. And just in terms of speed, we don't want to do any rendering that we don't have to, so we're only going to render most of the time the front side. And especially in 3D game engines, we're only going to render the front side, we're only going to do lighting calculations for the front side, we're going to very much limit the amount of computation that we do. So we have to define a front and a back side for each triangle. And the way that we do that is by the winding order. And basically we look at, from the 3 points, how we actually lay these out in this triangle array. So we have 1, 2, and 3. And we can either go clockwise, or we can go counterclockwise or anti-clockwise. And so, if I have those 3 points defined clockwise from where my camera currently is, then I'm looking at the front of this particular triangle. So with winding order, clockwise means that it's visible. Now if I have the 3 points defined in such a way that from my current vantage point they appear in counterclockwise order, that is then going to be invisible. I'm looking at the back side. Some shaders will actually render both sides of a object, so it doesn't really matter at that point whether you're looking at the front side or the back side. But most shaders that you're going to use in real time, so most shaders that you're going to use in game engines, just for the sake of computations, they don't want to do an extra pass if they don't have to, they're only going to render one side. So again, at a minimum, we have to have vertices and triangles, and we have to describe them in some kind of winding order. And then from there, if we want to have any kind of a texture applied, you have to have UV. But you don't always have to have UV. If I'm just going to be applying a color to an object, then it really doesn't matter what the UV is going to be, so I don't even have to apply it. I'm not going to be sampling any textures. And we can also have a UV2. So we can actually define a couple different UVs, and then we could use those for different images if we're going to be applying a couple different images through the shader. And finally, a little bit more discussion on normals. Normals are typically used to define a hard versus a soft edge. So when I have two triangles that connect, I have an edge that's formed. And typically in 3D space, they're not going to be on the same plane, so this might define a box, in which case I have a 90-degree difference between my two triangles. And since we're rendering, we can't perfectly describe objects. We have to approximate them as a series of points. So we're never actually going to have surfaces that are perfectly smooth. We have to approximate that surface as a series of points. And then the rendering engine needs to know which of these should be considered a hard edge and which should be considered a soft edge. And normals is how we do that. So if we just define, say, an example like so. If we wanted this to be a hard edge, then we'd have a normal that was pointing straight out of each of these two triangles. So I'd have a vertex assigned for this triangle, its normal would be here. I'd have a vertex at the same point assigned to this triangle, and its normal would then be over here. And that then tells the shader that this is a hard edge because the normals are not coincident. They're not pointing in the same direction. If I then wanted this to be a soft edge instead, then I could just use one vertex, or I could still use two. I just have to make sure that they all have a normal in the same direction. And then we'd have a normal here, and a normal here. And in that case, Unity or whatever game engine would then smooth between these normals. It would create a smooth edge rather than a hard edge. So that is a wrap on all of the basics of working with 3D meshes or 3D models. And again, this applies to scripting and to procedurally generating them within Unity, and it also applies to other 3D game engines, to other 3D modeling programs, anywhere you're going to be using meshes.